11.2, events involving not and or. Before we get into using not and or, let's talk about properties of probability for a second. So let E be an event in sample space S, within the sample space S. The following properties are going to hold. So the probability of the event happening is always going to be between 0 and 1. So if the probability of an event is impossible, then it's going to be 0, which means event is impossible. If the probability of a certain event, like it's going to happen, then it's going to be equal to 1. So the event, so the probability is certain, it's going to happen, then it's going to be equal to 1. So we could do some examples of this, right? When a single fair die is rolled, find the probability of each event. The number 2 is rolled. What is the probability of this? There are 6 possible results for a die being rolled, 1 through 6. So there are 6 total outcomes, and there's one event that is favorable, which is 2 in this case. So favorable outcome in this case is 2, and total possible outcomes. So the probability of this is going to be P of 2 is 1 over 6. A number other than 2 is rolled. Well, there are going to be 5 other numbers: 1, 3, 4, 5, and 6. So the probability other than 2 is going to be, remember, we have 6 total outcomes, and we have 5 that are favorable because we're looking for one that is other than 2. And there's 5 possibilities. So the probability of this is 5 over 6. Now, what about number 7 being rolled? Well, there is no possible outcome for 7. So P of 7 would be, there's going to be 0 favorable outcomes because 7 doesn't exist on a die. So it's going to be 0, which tells us this is impossible. And our last example is going to be a number less than 7 is rolled. Well, what numbers are on a die? 1, 2, 3, 4, 5, 6. So there's going to be 6 possible favorable outcomes. So a number less than 7 there's going to be 6 favorable outcomes and 6 total outcomes, which leaves us with a probability of 1, which is certain. Like we know a number less than 7 is going to happen. Now let's look at events involving not. So when we're looking at not, the probability of a complement. So the probability of a complement for the event not E. Will be as follows. It's simply 1 minus the probability that it will occur. So the probability of not E is simply 1 minus the probability of the event occurring. And if we added up the probability of the event occurring and the complement of the probability of the event occurring, it's going to be equal to 1. So P of E plus the probability of the event not occurring is going to be equal to 1. And that's where we get this formula from. So let's do an example. When a single card is drawn from a standard 52 card deck, what is the probability that it will not be a king? So probability that it will not be a king. Well, we can do this by finding the probability that it will be a king and subtracting it from 1. So the probability of a king is going to be 4 over 52. This is our probability that it will be a king. Well, what about the case where we don't want it to be a king? We simply do 1 minus this probability, which gives us 48 over 52, which is will not be a king. And that's how we use complement and not in this case for probability. Let's do another example. If 5 fair coins are tossed, find the probability of obtaining at least 2 heads. If we were to do a tree diagram, there's going to be 32 possible outcomes. So total amount of outcomes for this would be 2 to the n. And if we're tossing 5 fair coins, it's going to be 2 to the 5, which is 32 possible outcomes. And we're looking for the probability of obtaining at least 2 heads. And the outcomes would be tails, 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 heads, tails, 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 heads, tails, 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 heads, tails, and tails, 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 heads. So these are the outcomes that would occur with tails being in there. And with 2 heads not being in there. So it's a lot easier if we just do 1. So the probability of there being at least 2 heads is just 1 minus the complement of that. And in this case, there are 6 out of 32 which contain outcomes that don't have at least 2 heads. So it's going to be 1 minus 6 over 32, which gives us 26 over 32. So this is the probability that we will have at least 2 heads. Now let's look at events involving OR. So OR can be thought of as the union and addition of probabilities. If we do an example, if one number is selected randomly from the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, find the probability of each of the following events. So if we're given the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the probability of the following event. The number is odd or a multiple of 4. So we know that the odd numbers in this set are going to be 1, 3, 5, 7, 9, and the numbers that are a multiple of 4 are going to be 4 and 8. So the probability of getting an odd number is going to be 10 outcomes, and we have 1, 2, 3, 4, 5 favorable outcomes. Similar for this, we have 2 over 10. And so the OR in this case will tell us that the outcome, the probability of getting either a odd number or a multiple of 4 is going to be the union between these two, which is 7 over 10. That is the probability. Now, what if the number is odd or a multiple of 3? If the number is a multiple of 3, it's going to be 3, 6, and 9. And if we were to use the same strategy that we used to find for A, it wouldn't work, because let me show you. We want to find a number that is odd or a multiple of 3. So if it's a multiple of 3, it's going to be 3 over 10. And if we were to add these two, so 5 over 10 plus 3 over 10, 8 over 10, this probability is wrong. It would not work in this case. It worked in the first example because they are mutually exclusive events. But in the second case, they overlap. So the way we would do this is by from the following. If A and B are any two events, then the following holds. P of A or B is going to be equal to P of A plus P of B minus P of A and B. So to get the actual value for this case, we would do P of A, which is going to be 5 over 10, because we're looking for numbers that are odd, plus any multiples of 3, which in this case is 3 over 10, minus P of A and B, which in this case is going to be 2 over 10. So then we're left with 3 over 5. I'm sorry. It would be 6 over 10 simplified to 3 over 5. This is the correct way of doing it. If the two events are mutually exclusive, meaning that they are disjoint sets, then you could just simply do this. A or B is equal to P of A plus P of B. And we saw that with the first example, where being an odd and being a multiple of 4 are two mutually exclusive events, so we could just add both of them. If a single card is drawn from a standard 52 card deck, what is the probability that it will be a spade or a red card? Spade or red card. Well, what can we tell? These are two mutually exclusive events, because a spade can never be red. So we know the probability of getting a spade would be 13 over 52. And the probability of getting a red card would be 26 over 52. So we could just add both of these. And in the end, we get 39 over 52, which is simplified down to 3 over 4. So that is our probability for it. Let's do another example. Find the probability that a single card from a standard 52 card deck will be a diamond or face card. Well, these are not mutually exclusive because a diamond and face card can occur simultaneously. Like a jack of diamonds can occur, so they overlap. And we know that if we're doing that, it would be P of A plus P of B minus P of A and B. So what is the probability of getting a diamond? Well, there are 13 diamond cards in a deck, so it'd be 13 over 52. Probability of getting a face card, there's only 12 of them, so it'd be 12 over 52 minus the probability of both being a diamond and a face card. Well, there's only 3 of them, so 3 over 52, which leaves us with 22 over 52. Simplify that to 11 over 26. So that is our probability for this. Let's do our last example. Of 20 elective courses, Emily plans to enroll in one, which she will choose by throwing a dart at the schedule of courses. If 8 of the courses are recreational, 9 are interesting, and 3 are both recreational interesting, find the probability that the course she chooses will have at least one of the 2 attributes. So if R is denoted as recreational and I is denoted as interesting, then the probability of getting a recreational class will be 8 over 20. The probability of getting an interesting class will be 9 over 20. And we're looking at the probability that the course she chooses will have at least one of the 2 attributes. But we also know 3 are both recreational and interesting. So what we have to do is subtract P of R and I, which is going to be 3 over 20. And we're left with 14 over 20, or 7 over 10 for our probability.